we went through the HDFS system and how to store the large data files into the from client to HDFS system. So for this, actually, we have seen like how it has distributed across the cluster nodes. So that is nothing but data nodes, and we have seen the how master node give the it will generate IDs for the each block, and it will store everything, right? So this is what yesterday we have seen. And we have seen this also, like any big data, why we are going for that? We are going for that, like it is write once and read many times. And dividing big blocks into, it is distributed across the cluster. Cluster is nothing but what? Cluster is nothing but a compute. Compute is nothing but what? We are having a processor, network, and memory. Okay, RAM and ROM, disk and in memory. We have seen the difference between in memory and disk also. So in memory is nothing but, which is a temporary memory where we are working now. Okay, so store multiple replicas for each block for the reliability. Reliability is nothing but what? High availability of the data. So it is storing the data in different nodes for multiple times. The multiplication factor would be the 3. So 3 times it is storing everywhere. So in each block is storing 3 times across the nodes. So if one of the node failed, then no need to worry. Another node is having the information, and programs can ask, where do the pieces of my file live? So for programs who will give the block IDs where the file exactly storing, it will given by the master node. And who will take care of all these things? The master node and cluster nodes or data nodes. Resource manager. Yes, very good. Resource manager. Resource manager, here we can consider YARN or masters. So those are not for the Databricks or big data. This is only for HDFS. Databricks, we will use standalone resource manager. We can see in the Spark, that is, okay. So name node and data nodes are daemons running in a Java virtual machine. So everywhere if I'm saying a node, either it may be data node or it may be master node in the Spark or in HDFS. Anywhere, if I'm saying node is nothing but backend, we are having Java virtual machines. So every code we are giving or whatever we are doing, that entire thing is going to be converted into Java and is processed. Okay. So anytime if I'm saying node is, you need to remember that there in the node we are having, second. If I'm saying node, means you need to understand that we are having a block. This is a node. Either it may be master node or data node. What we are having inside is two things. One is JVM. JVM is nothing but Java virtual machine, you can say. Java virtual machine you are having. And second part, what you are having in this node is catch. Okay. These two things are combinedly considering as node. You need to understand that. So whenever I'm saying name node, data node, we are storing that everything in the Java virtual machine. So name node follows some rules. Okay. Here we are having hierarchy, directory of the names, and file names. What is hierarchy? Hierarchy is nothing but where it is storing exactly. Okay. So in data node, you are having 1, 2, 3, 4, suppose block IDs. So that hierarchy will be stored in the name node. And name node will contain metadata. So what is the metadata? Metadata is nothing but permissions and ownership. Okay. How we are dealing with, who will go and see the data nodes data. Nobody, like it is not like that everybody can see and they can check the data. They need certain permissions. Okay, permissions and ownership. And what is ACL? Access control list. So access control list is nothing but node contains two blocks or two. One block is Java virtual machine and second one is cache memory. And now we need to understand access control list. Access control list is nothing but we will have three kinds of access in this access control list. One is owner, okay, reader or end user, contributor. Contributor is nothing but developer. You and me. Okay, developer. Owner, who is the owner? He is the admin. Who is end user? He is a client who are taking your or stakeholder who has given you the data. Okay, client. These three things are very important to remember. Even I'll show you these things in Azure Data Factory also. So they are also Azure Data Factory, Databricks, everywhere you will have this access control list. Not only in HDFS, you will have it in the Databricks as well as Synapse environment, and whatever the environments you are having, each and every environment, you will have this access control list. Access control list is nothing but owner, a reader, contributor. Owner is nothing but the admin who will give you all the permissions. Okay. And reader and end user. He can only read the data. He can't change anything. Okay. He can only view. He can only view. Okay. Developer, he will have the control like write, read, view. Write, read, view. 1 second. Give me a second. Okay. It is review. So contributor, developer can write the data, read the data, view the data. What admin will do? Admin will give the access. He can have all these privileges along with the access. He will give you the access, what to do, what not to do. That is why when you are working on the blob storage or something, it is like that in the for in any project, it would be like this. We are having production and development, right? So in the production and development, you can see if you are working, then you are having this knowledge. So in development, you will have all the like you can write, read, and whatever. You can delete one blob storage, or you can do anything. But when you are going into the production, it would be like that. You are not able to delete a container, or you're not able to delete a file. Why? Because that access has restricted in the production. Because production is the ultimate final product where we are deploying, right? So that's why this access is going to be reduced. So reduced or restricted to some level. So they won't give access to all your colleagues who are having, and they can do whatever they want in production. It is not like that. But in development or sandbox. So for these two areas or environments, you can have the access. But there you don't have the access. Why? Because it is a restricted thing. So those who they were thinking, those who are your team leads or somebody who is somewhat superior, they will get only this. And we will ask them to delete the container, to delete the files, because that is production. So we must be more cautious. So this is what the access control list. So we are having access control list, block size and replication level. So metadata is nothing but which the name node is containing, right? So in this metadata, you will define it. So what would be the block size? What would be the replication level? Replication level is nothing but what? Replication factor, right? Here, standard factor, we are taking 3. Block size standard, we are taking 128 MB. We are taking 128 MB. That is so, and access and last modification. So when we have modified lastly, okay, that is what. So this is, and what is the user quota? Okay, block map. Block map is nothing but file names and block IDs. So file names, what is the file name we are having in this data node? And what are the block IDs? So we have divided into number of pieces, right? So number of pieces, suppose if I'm having block 1, in that block 1, I'm having 567. This information who will carry? This information is carried by our master node. So data node is having only file data, but master node is having all this information, metadata and hierarchies and data directory names, file names, IDs, and who is having the permissions, what are the ACLs and all these things. So this is the importance of master node. So if master nodes fails, then we are having another secondary name node. It would be always in ideal state, always in ideal state. Whenever this fails, that will come into the picture. So we need to understand what is exactly metadata and the difference between big data and metadata. Okay, a large volume of complex data that is difficult to process using traditional data processing application software. So big data is nothing but it is not like we are having 1 MB, 2 MB or such kind of data. We are having in TBs and terabytes and petabytes. So that kind of information, that kind of data, it is not possible to process through your traditional databases. Whatever you are having, your SQL, DBs and all, it is not possible to process through your traditional databases and can be informative or not, because it is like that. There may be junk data, there may be nulls, the data may be corrupted. So you can't say that by getting one file, it is more clear and you can work on it. Sometimes you will get corrupted files also. So at that moment, your system, like whatever your ADF or your Databricks is not going to work on that. You need to check the data before you are loading that file into your particular tools. Okay, not always processed. That is right. That's why we are here, right? So we are here to do the processing of the data. That's why it is not always processed and it is not always a clean board where you can work on your data. We are making that clean and clear, and we are doing the refinement of that particular data. Okay. Allows NoSQL databases to store data with large quantity, might large quantity, high velocity, and various types. This is all about big data only, because NoSQL is one thing where you are not using any coding. So there you can store the data and you can do that. High velocity is nothing but what, where the data is coming in, it is coming continuously with large volumes. Okay. Metadata. So what is a metadata? Data that describes other data. That is right. Suppose if I am having a table. So I'm taking one Excel file. What is the metadata of this table? If you see here, name, age, role, salary, and joining date. This particular information is nothing but metadata. Okay. And whatever the data you are having here, that is data. But the information about the data, the information about the data. So John, who is John? John is a name, right? And what is age? Suppose this is all you can see here. Is this data is properly organized? No. See here. In the name, you got age here. And instead of age, you got 30 number. But system can't understand like this. You need to define their data types, right? So if I'm defining this as string, it has to be string only. So string can contain numbers, but here if I define this as any integers or anything like that. So if I have defined this as integer, then I have given, or that data entry operator has given unknown and 30, right? This will fail automatically, because this is what unprocessed data. You are having data like this. You will receive in real time also data like this, because the data who is entering in the system, they were not data engineers. They don't know. They know just they can type it, right? So this is how you will receive the data. If you receive like this, then you need to process this data completely. Okay. So if I mention this age as integer and name as string, and I started throwing this data into my ADF or Databricks, what it will say? It will process first one. Okay. John, age 30, engineer, salary, fine. So it will send one particular row or record, and second record, it will throw you the exception. Boss, I don't know, some age column, which is not a data type issue, which is not an integer. Then you need to go back and you need to check the data. It would be like that. And at the ninth row record, it will throw you again the error. Also, I don't know. Some name column is containing integer values. So I'm not able to send this data to the blob or somewhere where you are targeting. This kind of information. So this information, this particular information can be called as metadata. This information is metadata, and entire this information you can call it as data. So this metadata will be stored where? It will be stored in the name node. And metadata would be always informative. It should not be like corrupted columns and all. If you are having that kind of corrupted columns and you can't define that column itself. So it should be always informative. If you are not receiving the columns properly, you need to mention this to your client I'm not receiving the columns correctly. So please send the columns fields correctly like that. Then they will correct it and they will send it to you. Always processed. It should process at their end, not our end. Okay. Because the information about the information, which is nothing but the metadata, is more important for us, depending on the metadata. In going forward, you can see that how we are defining, how we are giving all the metadata information, and then we are getting all the data information inside. So metadata, if you are not receiving properly, you are not able to do any data engineering over there. So always it should be processed. Helps to understand the nature and feature of the data. It is right only. See, you are having age, so you can understand the nature of this data. So by seeing this, everybody, even a small kid, can say these are numbers, right? So numbers is nothing but integers. So this is the nature of the data. So what it will define. You can see here, we are having data inside the bottles. Okay, what is metadata? It is having juice. So it has written on the top of the bottle, it is having juice. So juice is nothing but, it may be either orange juice or apple juice, whatever it is. This we don't know. We know that that is a juice. And again, this is an oil. We don't know which oil that is. This is poison. So it would be like that. The metadata will give you some information about the content, what we are having inside it. Okay. This is something what metadata. Well, this we already discussed. So data blocks in Hadoop, it would be 128 MB, and the blocks would be, the file is going to be divided into number of blocks. Before going into MapReduce, I want to give you some clarity about the big data. Big data is having two things in it. Why, what happened? Big data is having two things in it. One is storage, like HDFS or Spark. Second one is process. See, MapReduce, or Spark. Okay, both are same. Spark can deal with both storage and process. So storage is nothing but where, how you are storing the data. See, big data, people will get confused. This looks simple, but when even after explaining MapReduce and all, if I go through Spark and again I started explaining, you will forget this concept. Don't never forget this. So big data will give you two things. One is storage, how we are storing the data. Second one, process. After storing the data, how we are processing the data. Processing is nothing but like how you are splitting the data, you are giving the data to your end user. So this is process. So these two things are very important in big data. What is the purpose of process is analysis. So you are storing means what here? It is writing. So you are storing the data And what you are doing, analysis is nothing but reading multiple times. So what we are having in big data, we are having storage and process. Big data is nothing but what? Big data is nothing but historical data. Big data is nothing but historical data. This is not the OLTP data. This is OLAP data. Historical data, which is nothing but OLAP. What is OLAP? Online
Analytical process.
analysis. Very good. Analytical process or anything. So what happened is actually we are using Google daily, right? Google and Yahoo. What are those? Google and Yahoo are search engines. Google and Yahoo are search engines. What is search engine? Search engine is nothing but you can search anything in that, right? So how this Google works? Have you like you gotten your have you ever think about that? Ever thought about that? Like how Google works exactly? Because whatever you are asking, it will give you, right? This is Yahoo, what I'm using now. So suppose I'm asking what is data engineering. I just asked this question. So it is giving all the results. What is data engineering? Right? The process organizing, managing, and analyzing amounts of data. This is fine. Why it is giving like that? How it knows like we are questioning that, but how it is giving you the content? Have you ever thought about it? Suppose if I'm giving the same query like this, data engineering is what? It will give same result. Have you tried like this? No, I'm just giving. So it is giving, even if you give different shuffling words, then also you will getting all the content. This question, is it right? What I have given, this is wrong. But how it is giving, it's not depending on your question. It depends on your words, what you have given there. So whether you are forming a correct question or not, whatever words you have given, it will take the words. It never takes the grammar. It will take your words. Suppose, let's try differently. Any volunteers? Any questions to try here? Mm, okay. Any question? Like we can search here with with shuffling the words. Okay. Who's invented Python? So this is the question. Actually, I'll give in different way. It is directly giving history of Python. It is not throwing any error. Whatever you ask, it will give the answer. Even whether it is in proper format or not, it will give you the answer. So how it is giving? This is very important. So this Google search engines based on your search keywords. So it works. Google and Yahoo search engines works based on your keywords. This is what. So suppose if you are having Python code, I'm just explaining, even anywhere, any programming you are having, okay? There what you will have? Loops, for loop, right? For loop you will have. What for loop will do? For loop will do, it will iterate through each, it can read each item, right? For loop will work on the item basis, and it can do any operations which you have mentioned on the top of it. So suppose if I'm having a list in Python, okay, so list is how it looks. Suppose I'm having list in Python. So if I apply a for loop on the top of it, what it will do? It will take each and every item from this. It will take first item, will process it, and it will take second item, it will process it. It will take third item, it will process it. It will take fourth item, it will process. So what it will do? It can read each item and it can do operations on the top of it. So this is what list is doing, right? So here you are giving keywords, right? Keywords would be gone through one looping system. So each and every word is going to be processed. This is what the concept where we are calling it as map reduce. Okay, this is very important. Map reduce. What is map reduce? Map reduce is a process. It's not a storage. So map reduce is a process. All the Google and Yahoo or whatever search engines you are having, they will follow this. They will use this map reduce technique. Map reduce. We will see that what is map reduce. Okay. So map reduce technique. For the map reduce, for mapping, we are using for loop. This is a map function, which is nothing but collecting. Reduce. Reduce is nothing but aggregations. I can give you best example here. Aggregation. Suppose what it will do is you are having, suppose if 1 lakh people asked today, who is the PM of India? Okay. If this question is asked to Google, what it will do is it will collect all the information from all the customers and it will store it one place. So whenever you type who, then it will give the most highest asked question here. So it will collect all the words. So if I who is if I give asked like this, it will give you the series of questions asked by the people. Okay. This is what the collection of the words. Reduce is nothing but aggregation. So it will reduce. Suppose today 1 lakh people asked who is the PM of India. So then this PM would be collected for how many times? It is collected for 1 lakh times. So this is the aggregation. So total 1 lakh is the aggregated value. And for loop, it will run through who is the PM. So it will store who how many times asked, is how many times asked, the how many times asked. So this information is stored at Google search engine. So whenever you are trying to ask a question, it will directly give you without wasting your time due to this map reduce. This is aggregation. Okay. This is what you call top searched results. Top searched results. You will get that. Okay. See here. In June 2025, these are the most popular searches. See here, you can see ranking they have given. How they have given the ranking depending on the search volume. This is your search volume. So in US, almost this many people searched about YouTube, and this many people searched about Amazon, and this many people searched about Facebook, and weather, Google, about Google, this many, Gmail, this many opened. And see here, you are having all the list who searched, and you got the rank also. This many people searched about, almost 50 lakhs people searched about Apple. Apple is nothing but, maybe it is an Apple product or an eatable apple, or it may be anything. So that is a keyword they got this many times. Pizza Hut, McD, flights. So you are getting like this. See, if I typed like this, most searched, top searched results, then you are getting. So what is happening at the back end? Google or Yahoo is taking MapReduce function. MapReduce function will collect the keywords, and it will collect the aggregations. How many times this word is posted on the, or questioned on the Google, and this is this many times in only June month. June month. Okay. So this is a MapReduce. We will see what is a MapReduce. But you try to understand the back end, then it would be easy for you to get into the clear picture. So read is nothing but multiple notes, write also on the multiple notes, right? So I'm just sharing this. This is a MapReduce. So this is an input to any search engine. Okay. So what? Welcome to Hadoop class. Hadoop is good, Hadoop is bad. Okay. This is an input given to any search engine. So this input is going to be splitted into number of nodes. See here. Welcome to Hadoop. It has taken into one part. Class Hadoop is. See here, from here to here, it has broken. And then good Hadoop is bad. So now it starts doing the mapping. So welcome how many times in this particular node? One time. To one time. Hadoop one time. Class one time. Hadoop one time. Is one time. Like that, it will give how many times it is coming. Okay. This is counted in the mapping. Okay. After counting this, what it will do is it will shuffle all the information at different node. All these are nodes. Okay. All these are nodes. From one node to another node, this information is passing. So this is the full sentence we are having. In this sentence, it is making us number of partitions and given to each node. This node, it will take mapping. Under mapping, what it is doing? It is mapping with one number. How many numbers you are having. And again, in the shuffling, what it is doing? All the data is going to be shuffled here. So welcome is 1, 2, how many types in the entire statement? You can see 2, 2, 1. So it is coming 1. Is here 1, is here 1. Is shuffled to one block. And Hadoop is shuffled to one block. Good is shuffled to one block. So total how many blocks you are getting? 1, 2, 3, 4, 5, 6, 7. This is shuffling and this is mapping. Mapping is nothing but giving a number to your particular keyword. Okay. That is nothing but mapping. Map function can be, you can easily understand, for loop. Okay. Each and every item is running through one for loop. So for loop is assigning one value to that. Okay. So this value is counted here. Finally, reducer. Reducer is nothing but what we have discussed. Reduce is nothing but aggregate. So aggregation is nothing but reducing. So we are having Hadoop how many times? 3 times. So 1 plus 1 plus 1. It is aggregated and given 3 value. Flash is 1. Good is 1. Ease is 2 times, you got 2. So this is what the reducer will do. Reducer is nothing but what? Reducer is nothing but aggregator. Reducer is nothing but aggregator. Mapping is nothing but furlough. Okay. What is shuffling doing? Shuffling will collect same kind of information or keyword. This is what. So finally, you are getting the output here. You are getting the output here. That is bad 1 time, class 1 time, good 1 time, Hadoop 3 times, is 2 times. So this is what you are seeing here. This is what you are seeing. This is a keyword and this is aggregated amount and this is a ranking. This is nothing but what you call, this is nothing but map reduce technique. Any doubts still here? Are you following or how it would be? Right. Now let's go into the how exactly. By understanding this, you can easily understand what is disk disk to disk and in memory processing. Okay, so this is very important to understand why we went for the Spark. Now you have to understand this one. This is just I'm giving any DB how it works, but I'm taking an example of SQL DB. Okay, because SQL is more familiar to everybody. So I'm taking SQL DB, but any DB how it works, you can see here. We are having one Spark context, or this I'm taking SQL, right? So I'm saying SQL context. And we are having one SQL client. Okay. So SQL context. Any traditional DB, it will have like this. So what is this? You are having here database. Where this database stores? Database is nothing but RDBMS. Relational Database Management System. Where it will where it is on disk. I'll highlight this. Disk. Okay. So now, whenever you are trying to, this is a SQL client. SQL client. Who is SQL client? Where you are giving your queries, simple queries. Okay. Queries you can give here. Fine. So first of all, what happens is whenever you are starting to give one code or something, one query, then what happens is first thing it will happen here. Okay. One SQL session is going to be established in between SQL client and SQL context. So SQL session is going to be it will be established between SQL client and SQL context. Without this, it is not going to be connected. So who connects this? This is connected by SQL. Session is established in between client and context. SQL session. Next is fine. So now what happened is we need to send the data to context to client. I'm just querying select count star from a table. So where is the table? The table is on the disk. So from disk to client, what we need to do? We need to send the data. So for that, what we are doing? We are taking one block. This would be the data. Data can be sent to SQL client. Okay, data can be sent to SQL client. To send this data, what happens is exactly there would be one SQL cursor. Okay, SQL cursor would be there. It will process in the in memory. In memory. This SQL cursor will on and it will process in the in memory. So to send the data from SQL context to SQL client, we are having an SQL cursor where it will work. This SQL cursor will work in the in memory. SQL cursor. This is will work in the in memory. So what is SQL context will do? SQL context will convert query to white code. This you need to understand. So this SQL contact is contacting with your disk. What it is doing? It is converting your query to white code. What is white code? White code is nothing but a binary code, which is a machine code. You don't know. We are giving this like this query. How we are giving English like query, right? This query is given to SQL context. What SQL context is doing? This SQL context will convert this query to white code. Where SQL cursor is working? In memory. So in memory. In memory is nothing but what? In memory is nothing but, come on. In memory is nothing but sleeping or what? RAM, right? So this SQL cursor is working in the in memory. That is why what happened is when after giving it to the RDBMS, we are having two blocks, two or three, how many blocks, I don't know. It is going to be depending on your query. It will be divided into number of blocks. And this blocks from the SQL context to SQL client, you will send the information through the in-memory. This is generally any traditional RDBMS will send the data through in-memory. I'm just not giving the arrows because it will consume some time. So you can see here, to the SQL client, it is processing through in memory. Because of this SQL cursor. In memory, it will apply operations what you have given. And again here it will sort that also in memory. This is for what? This is for complex queries. This is for this. This is for complex queries. I'm just explaining again. Try to understand. So, mm, so what I'm doing is I'm having one SQL context and SQL client. So what this SQL client will do, it will generate one SQL session. This SQL session is nothing but this is the authentication. Okay. SQL session is nothing but which is authentication to connect with the context. Once this authentication has developed from client to context, what will happen is you will send one query, you will write one query. Suppose some simple query, select query. Okay. If you have given the simple query, what will happen is it will SQL cursor will on and this SQL cursor will take the data and it will give it to your client for this simple query. So it is not having number of blocks, but where it is processing exactly, it is processing in the in memory. It is processing in the in memory. Suppose if I have given some complex queries, then what it will do is complex queries is nothing but where we are using CRTs and CTRs and all. So that is complex queries. You are writing subqueries. Okay. So if you are writing subqueries, SQL can't do it in one single step. So it needs to take multiple steps. For that multiple steps, it will take multiple steps for the complex queries. That all steps will be done in the in memory, not onto the disk. So here no disk will come into the picture. Only disk here we are having to display the data. We are seeing the client. Okay, so from disk to client, what we are using? We are using in memory process. Once the data into the disk, from disk is nothing but where you are getting, just assume this is like an input source. Input source. So from source where we are having the information. Source is always disk. So from disk to we are getting the information and where we are processing, the entire process is done in the in memory. Entire process is done in the in memory. So now for the large queries also, this is important for us. Even if you have any doubt, let me know. So this is very important for us. Here disk is there, disk is somewhere outside. We are doing each and every operation inside the memory. This is very important. So how we are doing inside the memory, Spark also think like, because in MapReduce what happened is, you can see here, for each and every IO operation or each and every stage we are doing, right? We are doing each and every operation. This input to input splits, mapping, shuffling. Here one disk and again one in memory would be there. And again in memory is here and again one disk. One in memory, one disk. In memory, disk. In memory, disk. So in memory to disk, disk to in memory. In memory is nothing but what? Temporary memory. So all this what happens is it will take very what you call, the speed is going to be very low and it will take too much time to do all the IO operations. That is what the drawback of MapReduce. So you are taking from disk and you are writing into mapping is done in memory, and in memory to again disk, from disk to reduce is done in memory, and again it is stored in the disk. This is what the MapReduce process. Due to this process, what is happening is it is taking more time and it is very dead slow, and it needs more disks to operate. This is all the drawbacks of MapReduce. Each stage passes through the hard drives. This is then they think like in database in RDBMS, what we are doing, we are writing once into the disk and we are reading multiple times through the in-memory process. But remember, RDBMS is for very small data set. It is not for the big data. It is for normal data sets. So they thought like Yahoo and Google, they thought, okay, it's okay. Why don't we implement the same thing in the big data concepts? So where we are having terabytes and petabytes of data, why don't we use the same concept like in-memory concept? Then it is becoming the more speedy, right? Sure. So MapReduce is a framework for each processing parallelizable programs across huge datasets using a large number of computer nodes, collectively referred to as a cluster. So this is what the MapReduce. We are having multiple nodes over there. For each node, we are driving that through the disk. And what is mapping? Mapping is nothing but where you are storing into the temporary storage. You are storing into the temporary storage and you are orchestrating the copies to another node. Okay, what is that? Another disk you are storing, and shuffle step. You are doing the shuffling over there to get your collected words. Okay, reduce is nothing but where you are doing your aggregations. This is what the MapReduce. So due to this IO, each repetitive operations, disk to in memory, disk to in memory, disk to in memory to disk. Due to all the stages, it is passing like this through the hard drives. Due to this, it is slow. That's why we are moving this to Spark. So what they were doing is they were replacing this disk with memory. So wherever you are having your disks, these disks are replaced by your in-memory process. There Spark came. Okay. So input only disk, remaining everything would be what? Come on.
Memory.
Sleeping. Oh, okay. So remaining everything would be memory. This is what we are doing. See, replace disk with memory. In memory is nothing but what? Where we are having temporary memory. So HDFS read input is a disk and we are iterating this through your RAM. RAM is nothing but in memory. So one time process you are having input and you are querying everything you are doing in the inside the in memory. So there it is a concept of regular or traditional database management systems. So it would be the 100 to 10, like 100 times faster than your network and disk. In memory is, if you are considering really a memory, I'll show you that. 2 more minutes, I'll wrap the session. But first place always goes to RAM, which is nothing but in memory. This is the fastest one in your systems. Okay. Second place always goes to your network. Network is the highest speedy one. Okay. Internet, right? Network. Third one is disk. Always remember this hierarchy. Always. Never forget this even when you are working, because it is very important. So first place always is in memory process. In memory is the highest speedy one. So this is, you can say, slow to high if you are taking. Disk is the slowest. The network is a little bit faster than the disk. Moderate, you can say. In memory is the speedy one, fastest one. So 100 times faster than network and disk. That's why Spark is very fast. We can see in tomorrow's class, but if you have any queries, you can ask me now. Okay. Shall I leave? Yep.
Yeah, just one question.
Yeah.
Not related to class.
Okay.
Like, I mean, you mentioned we have Python tutorials which were, I mean, teached by some other tutor.
Your voice is very breaking, Sai.
I mean, you mentioned we have Python tutorials which were taught by some other tutor.
Yes.
Could you share that?
Yes, that Shanmukh will share with you. And one more thing is that also today I'll give you complete Python tutorials. You can work on that accordingly. Okay. Anyway, it will take almost another 1 week to go into the coding.
Okay.
Yeah. Another 1 week you will so in this week you can practice and you can ask me questions. That will be shared by Shanmukh. Okay. By today EOD he will share it with you.
Okay. Thanks.
Okay. Yeah. Thank you. Okay, thank you.